Okay, so we've looked at different ways to summarize or display numerical data. So now we're going to do one more. We're moving into box plots, which is another way. But just to go over some stats that we will look at and have been looking at. So we've got the median, and just you might write that's a good measure of centre is the median. And we know we've been practicing that the median's found at the n plus 1 divided by 2, I'm going to say position, just shows you what number it is. And we talked about the range. Now the range is a measure of spread, okay? And it's like the largest data value minus the smallest. We are also going to start looking a little bit more about the interquartile range. So it's the middle 50%, and that's why it's a good measure of spread, because it doesn't include those outliers. So we know the centre 50% is like the best majority, yeah? It's good to measure that. So that is the IQR, and it's when you do Q3 minus Q1. So we'll have a look at that, and we know we can get these stats are in our calculator. In the calc, remember, under the one variable stats. So, okay, so just if you want to write a little reminder for yourself, that's where you'll find it. Okay, so what we do next is obviously we can often refer to the 5-number summary. So when we have a set of data, we will look at these 5 numbers. So that's where we have the minimum value, the Q1, this one's the median, the Q3 and the maximum. So often we like to look at the 5-number summary. And the best way to display the 5-number summary is the box plot. So this is like a way to display the 5-number summary. Okay, so here is an example of a box plot. So they've got theirs drawn like this way. We usually have them along this way. So where we have a number line, so here would be a number line. And then you have something like this, a box plot, okay? So the line in the middle will be what the median is. This one at the top of the box there, so we sort of call this the box, yeah, is the Q3. This one's the Q1. Now that dot, because even though it's an outlier, it's the highest, that would be the maximum. And down here, this is obviously the minimum, okay? So in a moment, we'll work out how we determine whether that's a maximum, whether it's an outlier or not, sorry. So here, this number here is the next number, the next highest number after that outlier, okay? So that's where that whisker goes out to. All right, so we're going to look at, this is a box plot, and we're going to look at different things and how to describe it and things like that. So the box plot can have a shape, and it can often have the skewness. And when we're talking about the shape of a box plot, we are mainly talking about this part of the box plot. So see how in this one, because this side is equal to that side, we would say that's symmetric, okay? So when we see, and we'll see the other ones, so then you can have positive skewed. So let's just go to the page and have a look. All right, so on our calculators, we're going to do, I'm going to show you how to do a box plot. So what I'd like you to do now is I want you to enter in class A. So the first thing we're going to do is go to lists and spreadsheets, and we're going to create a list of class A, and I'm going to pause it. And okay, so as we saw on the calculator, we created our box plot, and you could see that you could hover over with your the hand, and it'll tell you all those things. All right, so we also here, so we put the list in, here's how we created the box plot, and as I said, you can hover over. Now this one had an outlier, so we would think, so be careful, you have to draw that little whisker out to 21, I think it was, and make sure that's all done. Now, here's when we added another one. So what we're going to often to do is they're going to ask you to compare or comment on what these box plots. So when you comment, so say class A, what we're just going to comment on is the same things we always do. So the shape, and if you have a look down here, these are on another page on your notes, so don't stress, but I've just moved them here so we can see. So the shape here of class A, can we see that this box at the start is bigger than the second one? Would you agree?
Yes.
Yeah, so when that happens, it is negative skewed. Can you see down here? It has the box at the start is bigger. So class A, we will say negatively skewed with an outlier, doesn't it? No, it's negative skewed with outlier. So we've said negatively skewed with an outlier. Make sure you comment that it has an outlier. You have to do that. Now, the other things we have to talk about is the centre. So you would just hover over the median and we'll just say it has a median of 27.5, okay? Now, we'll want to talk about the spread. When we're doing box plots, because particularly too, because this one has an outlier, we don't want to use the normal range. That's not a good indication. So for the spread, we would use the IQR. And so the IQR is when you go Q3 minus Q1. So up here, I hovered over this so we can see. So Q3 is actually 32 here and Q1 is 21.5. So what's the IQR? So that's 11.5? 10.5? No, 11.5. Okay, so that's the spread. And that's you commenting. So then if we look down at this, I'll just go work with you and we'll do class B. If we look at class B, its shape, and if you have a look, it's this one's a little bit iffy, but I'd say maybe this is a little bit smaller than this second bit. So I'm going to say positive skewed, okay? So we'll say positive skewed, no outliers. The centre, I think I hovered on it, it's 19. And the spread, we'll use the IQ, oh God, I can't spell, the IQR. So it looks like, I'll just hover on I've got it on my computer. So IQR, Q3 was 29 and Q1 was 10.5. Okay, so you do that and then work out the spread. All right, now what they often do is ask you, so we were looking at class A and B, and what they'll say is, do you think that which class you are in has an association with your mark? Now, looking at just this data, I'm going to say, yes, there's an association with the class that it's the class it is and the mark they got, because I'm going to say class A has a higher median score with 27.5 compared to class B with a median score of 19. Okay, so we'll go over this. If there's a difference, there's an association. So there's a difference in median there, isn't there? Yeah? One's higher than the other. All you have to go is that if there's a difference, there's an association. If they were the same median, you sort of say, well, it doesn't matter what class, it seems like the mark was the same. All right? So we'll keep going. So here, so we've done all that, and we'll do a little bit more of the explaining. But what I wanted to talk about here is you don't have this page, I'm just using it to explain. When we've got this box plot of this class A, we ended up with this outlier out here. So how do we determine an outlier? Is that we have a rule, and it's what we call an imaginary fence. Like, it's there, the computer, we calculate a number, and if a number's higher than that number, it becomes an outlier. So what we call this one up here, we call the upper fence. And the way you calculate the upper fence is there's a formula, and it's Q3 plus 1.5 times the interquartile range. Okay, that's how you determine the upper fence, and then the lower fence is Q1 minus 1.5, the interquartile range. Okay, so if I go for this example to show you, I'm going to use Class A. So Q1 was 21.5 minus 1.5 on your times. Now the interquartile range is Q3 minus Q1, okay? And what you have to do is you do that on your calculator and get an actual number. So we'll go do. Okay, so sorry, I got this to be 5.75. So what I'm saying is any number lower than 5.75 is an outlier. Okay, so if they asked me in the test, they said show that 3 is an outlier, you would be showing this formula of the lower fence, and you would then say, therefore you go 3 is smaller than 5.75. Okay, so you can write it like that, or you can write what I just said. So if you look up here, there's no other number except for 3 that was smaller than 5.75. And that's how they know 21 is the next smallest, and that's why that whisker went to 21, okay? Because that's the next smallest number. Okay, if we did the upper fence, we would do 32 plus 1.5 times the interquartile range, which is still the same, okay? So if we do that, just remember it's plus, not minus now, so 32 plus, and I get 47.75. So there's no number bigger than 47, and that's why the 43 is the last one, and that's why the whisker goes up to 43. Okay, so just to summarize our test for outliers, so you've got this in your page. So what the formula for upper fence I just showed you was this. What I've written here is actually what you're going to type in, isn't it? Because you can't type the word IQR in there. So the IQR is Q3 minus Q1. So that's why that's written like that, yeah? So this is what you would type in your calculator when you're finding the upper fence. And then obviously if you've got the lower fence, this is the formula I wrote, but this is what you would type out in your calculator to find it. So to go over, that's a test, that's how you test for outliers. So this one was obviously above the line, and you can work it out. So even if you're given a box plot, you can prove, say they told you that was, I don't know, 56 or something. If you've got all the numbers you can read off, you could prove that because you've got everything you need for the test for outlier formula. So here, down here, we're just going over describing the shape of a box plot. So if it's symmetric, so remember our symmetric histogram looks like this. If the box plot is symmetric, then the distance between the median and Q1 and Q3 are very similar. So what I'm saying is this size is the same as that side there, okay? You don't need to worry about the whisker part, okay? It's just the center part of the box. So if you look at positive skewed here, the first box here is small and the second one is large. Okay, and it indicates that tail. See, there's the tail. This is the tail. Okay, and then in negative skewed, you have the tail at the start, and that's why the box is longer at the start than at the end. Okay, let's just go through a few exam questions. So this was out of the 2016. The weather station also recorded daily maximum temperatures, and we can see the 5-number summary has been given to us here. Okay, really important that they told us there's no outliers, because from the 5-number summary, they want us to draw a box plot. Without the data, I couldn't be sure whether there was an outlier or not, so they had to tell me that. And so all you had to do is just draw it in. So 16 was here, then you've got Q1 at 21, so you draw a bigger line there, the median at 25, Q3 at 31, so there's my middle box, and then up to 30, 6, 7, 8, 38 here. So you just would make sure your tails are out like that. Okay, so what type of, if we're just having a look at that, what type of shape do we think this one is?
Positive skewed.
Yep, I would go positive skewed. Where's the center?
15,
Good. The
25.
center is the median, which equals 25 degrees Celsius. And what is, if we did the spread, remember that we'd use the IQR, always use, if you can, use the IQR, because it's 31 minus 21, so 10 degrees is the spread. So the majority, 50%, ranges between 10 degrees. Okay, the box plot below shows the distribution of forearm circumference in centimetres of 252 people. So, you could get a lot of questions on this, and obviously you would have. So there's something they're giving us, the total there. The percentage of these 252 people, that was nice, because we know when we ask for a percentage, we've got to do the amount out of the total times 100. So we know that the total was 252. But here we don't need to worry about this, because they're saying with the forearm less than 30. So if we go up to 30, would you agree that 30 is your Q3?
Yes.
Yeah. So what we're going to talk about here is when we have a box plot, a box plot, say like that, from here to the end is 25% of the data. We know in here is 50% of the data, and there to there is 25%. So if we're going from Q3 onwards, we're from here on, how much is less than that if you add up all those percentages? It'd be? 75. If you were asked how many people, were less than 30, then we would say it's 75% of the 252, okay? So just be careful of what they're asking there. So the other thing I just want to make sure you are taking note of is it doesn't matter if there's outliers in there. Those outliers are included in that 25%, okay? Just be careful. Some few people get a bit tricked there. This bit is the 50%, and that bit is still 25%. So it includes the outlier. Now, if the other one I just want to talk about too is if they talk about if something's more variable. So that means that if it's more variable, the ranges are bigger. So that means in box plots, if I had say like this, oops. So say this was class A, class B, whatever. B is more variable, because can you see its middle 50% in here is bigger, isn't it? Yeah? So it's ranging a lot more around, where that class A, they're all getting close all around the same mark, all right? Okay, so the box plot below shows the maximum daily temperatures of the months May and July. Describe, oh, I've cut that out. For May, I think you had to describe the shape. Sorry, I think it was the shape. I've cut that off. So describe the shape of July. What's July's shape? What's this shape? It's positive skewed. What are we missing though? We've got to say something else.
With outlier.
Thank you. With outlier. So you wouldn't have got the 1 mark if you hadn't have written that. And what's May's shape?
Symmetric.
Yeah, I would go symmetric.
Yeah, it's the same as outlier.
Not really, because you've stated the one that has. So I think you're covered there. Okay, now it says determine the upper fence for July. So July's up here in the blue. Okay, so upper fence, write the formula is Q3 plus 1.5 times the IQR. So if I go up here, the Q3 for July is 11. Is that what you think? Yeah.
Yes.
11, and what's Q1? 8. So 11 minus 8. So you pop that into your calculator. So it ends up being 15.5. So can you see that's why this guy is an outlier, because it's higher than 15.5. Alright, so with the following, it says use the following information from the box plots and explain why the maximum daily temperature is associated. So I'll write what I said before. If there is an association, there's a difference. So if there is a difference in the same category stat, I'll just write the same stat, there is an association. Okay, so that's how you know there's an association. So what do I mean by that? If I look at this example, July's median is 9 degrees, May's median temperature is 14.25. There's a difference. There's an association. So what we say, if they'd been the same, we would say it doesn't matter what month you're in, the median temperature is the same. So it doesn't matter, but it does here. If you're in May, there's a higher median monthly temperature. So what you have to do, it says using the information, quote and use stats, say there is an association. So we'll write this. So we'll say there is an association between month and daily max temperature. Sorry, I've done that around a bar. And we say with May's median temp being 14.25 degrees Celsius, which is higher than July's, with a median temp of 9 degrees Celsius. So you're going to get the mark. This I would believe would nearly get 2 marks because they told you it's associated. So sometimes if they ask you whether it is, you're going to get a mark for saying it is, if you can tell, and then you get a mark for stating the stats. So the best way to state it is to use the medians if they're different. You can use other stats if you like. So we could say, because the interquartile ranges are different, yeah, that could also be used. So you could say that here, May is more variable, isn't it? Yeah? May more variable, because this is, this bit, this box is bigger than July's one. So May is more variable. You could have used that stat as well, and that would have been good. We would not use the range in that because that's got an outlier, and we wouldn't use the average because there's outliers as well. So this one, and that's it. So there. All right. Describe the shape of this back-to-back stem and leaf plot. I just wanted to show you this because we remember if we were doing them the other day. So if I look at Yarra Grove, if I look at Yarra Grove and flip it this way, we can see what the shape is. And what would you say the shape is? All right, so looking at this, what shape is Yarra Grove?
Symmetric.
Good. So shape is symmetric. Yeah, good, with possible outlier, I would say too. Because we're not really testing, we can get away with saying possible outlier. Because it might not be, but it looks like it, so we'll call it. Now, with this Warburton, what I said, you've got to be really careful with this one on the left-hand side. Because if you flip it, it's not the way that it should be. It's not smallest to largest. But if I flip it like this, there, so see how we've now got the smallest to the largest. So what shape is that when you got the tail at the start? So this one is negative skew. Okay, that's where you've got to be really careful with that one. All right. So here is just an example, so you can have it in your notes to compare. So you've got your two box plots. Women shows the distribution of ages of 45 men and 38 women when first married. So when you go to compare, what would we compare? So straight away, you compare the medians. So you'd say, comparing this, the men's median age was higher than the women's with whatever it is. And then you can go on, you could say the men's are more varied because this yellow box is bigger than the blue one. And you could also, and they've said that. And so you would say there's an association there. Or not really, they're very close. So it depends on how you're going to debate it. If you said the median age was pretty close, you could say it. All right.